So welcome again, TikTok electricians out there, aspiring electricians and electrical engineers and technicians. So today we're just going briefly now. I'm going to just run on my words of the day from in this video. I'm just going to do it more from electrical and electrical engineering standpoint, right? So our word of the day, let's start with the word resist. And when you resist something, what you do, you oppose a thing. Something come at you, you resist. So resist to withstand the force of or effect of material that resists heat. So it's actually a force is produced, and normally another force opposes it, resisting it. So that's resist. So we start with resist. Simple word, resist. Resistance, right? And what is resistance? Because all electricians are supposed to know what resistance means, right? And what it does, the effect it has on a circuit, whether it's a AC circuit, DC circuit, and also electronics, because resistance come up a lot in electronics. So resistance, a material or component property that opposes the flow of electric current, right? Right. So that's resistance, right? So you're putting up resistance, right? And probably you hear a lot about resistance, right? It was another context and so forth, and popular Bersama songs putting up resistance. So people Jamaica was here about resistance, putting up resistance. And Bersama say we're going to rub it out anyway, right? So we have what here now, resistor. And what is a resistor, right? So resistor now, this is what now the component now that we are using electrical engineering, right? You name it, a lot of it in electronics and so forth. Different type of resistors, different values. So resistor is a passive electrical component that restricts the flow of electric current. So it's really an electrical component, and it's a passive electrical component, and the opposite of passive, antonym of passive would be active. So passive, it's really stationary. Yeah? So the passive electrical component that resists the flow of electric current. So that's a resistor. So all technicians and all electricians, all electrical engineers, resistor, one of the building block of the in terms of what it can do, right? And so you have to formula with a resistor. So we know resistor here. Different values. So we come on now to another word, still coming from same line coming down. Resistivity, right? Right, although it's a big word, it's coming from the same, So what is resistivity? Resistivity is actually the resistance of a unit cube of a material measured across opposite faces of the cube. And the symbol is the Greek letter. The Greek letter, leave off the idea, the Greek letter rho, right? So this is a symbol, right? Rho, that's a symbol for resistivity. So what resistivity really know? Because all material, whether it's copper, aluminum, silver, you name it, right? Even the earth itself, by nature, naturally, it has resistivity. So this is a piece of copper conductor. And it has a resistivity, and we have the formula to find resistivity, the current, the volt resistance flowing through that piece of wire, depends on the length and the cross-sectional area of the wire. If I can find the resistivity of any material, you can also find the resistivity with of the earth. Sometimes you want to know the effectiveness of the earth. They have equipment that you can use to find the resistivity of the earth. So resistivity, I say, resistivity, the resistance of a unit cube of a material measured across opposite faces of the cube, and the symbol is Greek letter rho, right? So it can be, whether it's aluminum, copper, you name it, just about any material, it has its own resistivity. And copper has a better resistivity than aluminum. Right? So impedance now, and what is impedance now, right? So impedance is actually the total opposition to the flow of electric current in an AC circuit, and it is measured in ohms. So when we're talking about impedance, we normally we refer to an AC circuit, right, and not a DC circuit. AC circuit, alternating current, AC circuit, right? And impedance now the three components now that would make up impedance. Come across here, youngster. They show you now impedance now. The three components that will make up impedance. So impedance now consists of, and we think about an AC circuit now, consists of resistance, measured in ohm, right? Inductive reactance, right? Right, and that is the inductance that the resistance that is in an inductive circuit, right? Inductance, right? So we have that now inductive reactance, and that's the inductor, right? And it is XL here, inductive reactance now XL measured in ohm, and we can and this is the formula for it, 2 pi FL, right? And you know that pi equal 3.142, the frequency there, and the Henry there you use to find inductive reactance, right? The total opposition to the flow of inductance in a circuit. And we also have now capacitive reactance now. Capacitive reactance now is the resistance that a capacitor for the flow, right, of electric current. And that capacitive reactance XC is also measured in ohms, right? And the formula for it will be 1 over 2 pi FC, right? And that 1 and the 2 times the pi 3.142 times frequency times the capacitance would get your capacitive reactance, and that will measure in ohms. And when we put all three of them combined, we can use the power triangle there. We can now find the total impedance of that AC circuit, and of course that will be measured in ohms, right? So coming down here, so now a DC circuit, right? A DC circuit is a purely the wire, I leave off the wire here, is a purely resistive. It's a purely resistive circuit, right? The current and the voltage, they are in phase, right? So they are in phase. So now I'm going to say that's a DC circuit. The current and the voltage is in phase. So it's that now a purely resistive circuit, right? So, but that's the case now. When you come to an AC circuit, right, alternating current circuit, and especially a three-phase circuit, it's a different thing, right? So we have now an inductive circuit. So in an AC circuit now, right? An inductive circuit in an inductive circuit, right? The voltage normally leads the current by about 90 degrees. They are not in phase. So the current and the voltage are not in phase, right? The voltage leads the current. But at the same time, on the other hand, now we'll come to a capacitive circuit now. The current leads the voltage, right, by 90 degrees. So the current leads the voltage, right? So normally, normal situation now in an AC circuit, right, in order to correct the port, you have a lot of inductance because generally the transformer and things like, and the motors, things like this. I have a number of motors in the industrial facility. You have a lot of inductive reactance. So in order to correct that, hence you might have now a bad power factor. And in order to correct that anomaly, we normally use now overexcited synchronous motors, right? And you can have also bank of capacitors connected to the terminal of the motors. So when the motor turns on those conductors, it kind of that is made to adjust the correct power factor, right? So remember now in the AC circuit, as I said, finally impedance consists of resistance measured in ohm, inductive reactance, right? Inductor the coil, and it is XL measured in ohm, and the formula for 2 pi FL, capacitive reactance, right? Capacitance XC, it also measured in ohm, and the formula for it is 1 over 2 pi FL. And an AC circuit, in a DC circuit, it's a purely resistive circuit. The current and the voltage is in phase. However, when you come to the inductive aspect of it and the capacitive aspect of it, in the inductive circuit, the voltage is going to lead the current, and the capacitive aspect now, the current is going to lead the voltage, right? So this is just now for our road of the day. Remember now, electricians now, they know that's it. Get a good grasp of the English and memorize the correct term or the jargon and familiar with them. So when you're going now to take have a textbook and you're going to take an exam and interpreting the code, right? You will be able to understand what you are reading, because as I said, the code is not an electrical textbook. They are not written they are not written in patois or your local dialect or language, right? So if you want to be a successful engineer, electrician, contractor, you name it, right? If you want to pass your exam, whatever, you have to familiarize yourself with the correct term, right? And you see this textbook, the dialect, is an English book, right? And these are all English book, say, and all these things that's how it is written in here, right? And it's the American book. American might have their different way of pronunciation and spelling, but at the same time, the words will have the same meaning, right? Basically, so that's what I said. Also, youngsters now get a good grasp of the English language, and do your calculation, get buckled on the maths and the theory, and study the code, and you will, at the end of the day, you will be successful, and it will be much easier when you're going to take an exam, right? So remember now, so that's why I break it down here from what is resist, and what is resistance, resistor, resistivity, impedance, because that's how I normally, I know these words, and I will use what from other contexts, from my reading, from other things, and then it just come easy to me when I'm going through the electrical aspect of it, right? Because I was familiar with these roles from the beginning, from some other aspects. So that's it for today, electrician and technicians and aspiring electricians all over Jamaica, the North America, the diaspora, and Africa. Go on the page, sparkedu.com, and follow the link. The link is on the TikTok page there, and go on the educational platform, and we'll provide a lot of information and study material there that you can study and familiarize yourself and where we are, that you can get on board and study and pass your exam and be successful in whatever study you may undertake. Until next time, take care and see you, right?